In continuation to the previous video, in this video, we are going to see what multimodal RAG is and how can we try to implement a multimodal RAG using Llamaindex. So the blog which I'm currently referring to is published in Llamaindex blogs, and what I'll do is I'll attach the link in the description of this video. So let's start. It's a beautiful blog where they have explicitly mentioned what RAG is and what are the vector storages that they are using and how it works. And they have given a pretty good high level information on how this should be implemented in your own Python environment. So let's start. The author is Raghav Dixit, and this blog is published in Llamaindex. Currently, I'm referring the Medium uh, website for this. So this starts with what RAG is, and in the previous video, I have kind of explained you what basically RAG is and how it is used to get the result for the query that we are giving, but only from a certain documents or content that we have already uh, given to our system. So the core concept of RAG basically works on two principles. First is retrieval, second is generation. Retrieval basically uses semantic search. So all the documents that I have will be stored in some database, and retrieval will be on the question which I'm asking to my model. It will try to retrieve the most uh, semantically meaningful sentence which is related to my question, and it will try to locate it and retrieve it using this. And generation is basically it will give this keywords and the documentations which has retrieved from my vector storage to my LLM model, which will generate a response in accordance with the retrieved content which I have. Speaking about RAG architecture, he has mentioned that it involves a dense vector. Currently, in this specific block, he is using LansDB, which is a kind of vector storage. There are three basic actions that we are going to perform. First is semantic searching for our documents and then processing that document with the question or the query that I have given. And third is after retrieving that information to generate an answer. So extending to multimodality, the thing which we were discussing currently was only with one typical model, which is text model. But here we are going to work on text, images, audio, and video. This is multimodal RAG. What this video is doing is basically it is using a YouTube video or some video. It will process that video, and then I guess he's using OpenAI's clip model to get the text as well as video embeddings. So to tell you about OpenAI clip model, what I'll do is I'll just search in new tab what OpenAI clip model is. This model basically gives you a square matrix with uh, yeah. So if you see, this is your OpenAI model architecture. It gives you a square matrix where on the vertical side it has all the vectors of images, and on the horizontal side it has all the vectors of text. So this is how OpenAI clip model works. It will give you an embedding which will have image as well as text both together. So what he's trying to do is here there's a code for downloading a video from PyTube, which is a library which uses URL from YouTube and downloads it basically. And then what he's doing is he's taking that video into consideration, and at the FPS of 0.2, he's trying to extract a frame. So per second, with FPS of 0.2, what he'll do is he'll extract frames which will be, in this case, usually what we do is we use 30 FPS where there are 30 frames per second. But in this case, it is 0.2 frames per second, which basically means that in 5 seconds, it will generate a single frame. So after 5 seconds, after every 5 seconds, this function will take the frame and store it in the folder which we are going to use, the output folder. So after that, this function, what it does is it basically extracts audio from your video and gives you an audio embedding, audio file. And then audio is transcribed to text using some ASR model. ASR basically stands for speech recognition. It's a speech recognition library. And Whisper is a good model to try. So this guy is using Whisper. And Whisper again is from OpenAI. Whisper again is from OpenAI, which basically gives you a transcription of your audio. So it takes audio file as an input, gets a logmail spectrogram, and then gives you an transcribed text. It uses transformer as a base model. Coming back to our blog, what the next step, what we are going to do is we are going to use the LansDB vector store. Now, LansDB vector store is a model which is used to store the documents or the contents in a vector format. And we are creating two collections. First is text storage, and the name of that table will be text collection. Second is image storage, and name of that table will be image collection. And then he's creating an index which will be having all the documents, and the storage context will be this thing, which is having both the databases, both the tables, text store as well as image store. So this index will be object which will store the embeddings or the vector embeddings, and we can call all the vector embeddings through this index. So retrieving relevant images and context with the index in place, now this system can retrieve all the similar images and similar text based on my query. So there's a function in this Llamaindex index which is as retriever, and here it is using uh, the base or the default library for this is cosine similarity, I believe, and then there are other alternatives to it which can be used. So sorry, the LansDB uses L2 as an default, but we can use cosine or dot, and then using this, it can retrieve me the location of the document where the relevant document are there with respect to what my query or question is. And then retrieval function basically gives me results, which will have uh, the query string as an input, which will be your question. The query string will be, for example, let's say I have given it a video and I want examples from this video which explains all the Gaussian functions. So in this blog, what they are using is from 3Brown. There's a YouTube channel. They have used it, and there's a video of 3Brown 1 Blue about Gaussian thing. I believe the name of channel is 3Brown 1 Blue. Let's see. Okay. Yep. So this is the video from 3View 1. Let's expand the window. So yeah, so this is the video that he is using 3 blue 1 brown, and the name of the video is a pretty reason why Gaussian plus Gaussian is equal to Gaussian. And the query which it has given is, if you see, using example from the video, explain all the things covered regarding the Gaussian function. And what it will do is it will give you a list of images. So this image will be a list of frames which are basically your uh, frames extracted with 0.2 FPS. So it will give you the location of that index. And because we have used top 5, it will give us 5 images. You can see 1, 2, 3, 4, and 5. And Then what we can do is, after this, what we can do, we can take all the 5 images. We can see the frame which is occurring at the earliest position in this video and the frame which is occurring at the last position in this video. And then what we can do is we can literally cut the model, cut that video, and only extract the video which is from first frame to the last frame, and take that video as a output response to what our query is. So basically, pretty much this is what it is about the blog. Uh, it has also used OpenAI Multimodal, which is again an OpenAI thing, a GPT-4 version, which takes in everything as an input, and on basis of text and the images, it will give me a response. So there will be a context string, a query string. Context string will basically be my context, which is retrieved from transcription. Query string will be my question. Image documents will be the list of the frames. And on basis of this, it will give me a response. That response will be your response which multi-model RAG gives you. That's it for this video. In next video, we will try to implement it and try to see the lower level of this thing. Thanks.